What's poppin', dogs? Mr. Allen here with the triangle inequality theorem. We use this thing to determine whether or not a triangle can be made from the three given side lengths. So that's what we're going to do right here in each one of these examples. So first one here, I got a length of 7, 9, and 15. Maybe it's feet, inches, I don't know. A lot of times in math we don't specify units. Sometimes we do. Okay, so 7, 9, and 15. Can it make a triangle? How the heck do I figure it out? Well, here's how I think about it, okay? If I have my longest side, right, the other two, the shorter sides, have to be able to connect to make a triangle, make like a little peak, right? So if I took 7 and 9 here, 7 plus 9 is equal to 16. That is larger than 15, meaning if I had my 15 length here, my 7 would come up like that, and my 9 could come up like that. So 7, 9, 15. This bad boy right here can make a triangle, okay? And your teacher may want you to do a couple different things here. They might want you to say, okay, I've got 7 plus 9 is greater than 15, and then also show the other combos. Really, it's just the two small sides have to add up to larger than the third side, but the way the theorem is written is that any two sides must add to larger than the other side, the third side. But it's the small ones that really determine it, okay? So here I've got 16 is greater than 15. You could also then write, if your teacher requires it, 9 plus 15 is larger than 7. Oops, 7. And then also 7 plus 15 is larger than 9, right? The key one is those two small sides have to be larger than the sum of those two has to be larger than the third side. But some teachers want you to write all three of those. So you can say the phrase or write the phrase, any two side lengths add up to larger than the third side, or the sum of any two sides is larger than the third, okay? Cool. Enough. All right. On to this one here. I've got 8, I've got 6, I've got 15. What's 8? 8 plus 6. That's 14. Uh-oh. That is less than 15. So what is actually happening that makes it so we can't make a triangle? Some of you might already be visualizing this, but if I took the 15 again and I said this is 15, my 8 is going to come to like this, but my 6 is going to come up short, and now I have this gap here where it doesn't actually connect. Okay? So this can't make a triangle. I can't close it off. So not a triangle. Not a triangle. Cool? Yeah. Yes. A triangle. Whee! I don't know. All right, cool. It's good for those two. Let's do the next one. I'm going to switch markers. Okay. 3, 7, and 10. Well, 3 plus 7, that's 10. So that's not greater than. That's equal to. It's equal to 10. So that's not going to make a triangle, but what's going on? That's okay. So not a triangle, right? But what is it? What's happening, right? Well, let's see here. My long side is 10. 3, if it came over, it would actually do this. So I'm going to do this in a different color, actually. If I had the 3 come over, it would look like this. That's 3. And then my 7 would come over like that. It would just be like flat, right? They could connect. It just couldn't go boop. It just got to be a little bit bigger, right? 3's got to be a little bit bigger, or the 7's got to be a little bigger. Then it makes a triangle. But as it sits here, this thing just flat. Lame. All right, so it can't be equal to, right? Any two sides have to add up to larger than the third side. Okay, so two different scenarios where it's not a triangle there. Let's see what happens next, all right? 5, 5, 7. Okay, so 5 plus 5, that's 10, which is greater than 7. Yay! All right, so that's greater than 7. For me, that's enough information, okay? The two small sides add up to larger than the large side. Cool? But if your teacher wants you to show all combinations, that's cool. We know 5 plus 7 needs to be larger than 5. And I guess we can also do 5 plus 7 again, because there's really two of those combinations, right? These two add up to larger than that one. These two add up to larger than that one. All right? There we go. Check, check, check. And I'm going to write the phrase here because I have the room. Any two sides, how about this? Sum. I feel like I want to write this over again. Sum of any two sides is larger or greater than the third side. So they might be asking for, some words, right? Some math words. So there we go. Sum of any two sides is larger than the third side. Also, by the way, don't be afraid to like restart your sentence like I just had to do right there, where I was like, ooh, I could write this better, or maybe like a little more efficiently if I just started with the word sum. I was going to say any two sides add up to larger than the third side. That would work. But I feel like sum of any two sides sounds very bougie, math bougie, so I wanted to use that. Okay, cool. So we got a couple different examples here. Not a triangle, not a triangle. Yes, a triangle. Woo! All right, that's it. Have a great day.